Now earlier in the lecture I gave you this equation that the change in the freezing point or freezing temperature of any solution is going to be equal to K sub F times M. Now what in the world are those things? M is the molality of the new solution, and K sub F is called the molal freezing point depression constant. I honestly don't want to write that there because it's really long. The point is this: if you take any solution, or any liquid, it normally would freeze at a certain temperature, and you throw in some kind of solute, dissolves in that solution, it's going to decrease the freezing point of that liquid. But by how much does it decrease it? And how do we determine that? We determine it by using this equation. So in the problem it gives us the molality, M, as being 0.08500 for an aqueous solution of glucose. It then gives us the molal freezing point depression coefficient, or constant, as being 1.86 degrees C per molal. And then it asks us what delta T ends up being. So basically I just take K sub F, I take this term, put it in there, and I take this term and put it in for M. And then I just throw it in my calculator. You notice that the molals cancel each other out, and I'm left with degrees C as my units. Once you do that, you end up determining that the final answer is 0.158 degrees Celsius. That means then that the freezing point of water will be decreased by that many degrees Celsius under this concentration of glucose. So the correct answer is going to be negative then. So it will decrease the freezing point temperature by negative 0.158 degrees C.